heading is regression analysis, and the question is, can you perform a regression analysis? Now, regression is just a fancy word for all the statistics that you've been doing this term, in the sense of bivariate linear data. You can plot scatter plots, find correlation coefficients, and make predictions using the coefficient of determination. All that kind of thing is regression analysis. And a little bit more as well, which we haven't covered yet. Now, what 3C does is tells you all the steps of doing a regression analysis. So those are the steps. Now, as I said, the process of doing this regression analysis, which, by the way, you have to do for your assignment, this is what your assignment is all about, basically, is doing a regression analysis, is all stuff that we've done up to this point down to this one here, using the coefficient of determination to indicate. So we've done all that already. This other stuff, which is new stuff, I'll come to tomorrow. So hopefully I'll get down to here. Now, I don't think you need to copy this down, because I'm going to go through it one by one. So if you just trust me that the first thing I'm going to do is scatter plots, then I'm going to go to a slide about correlation coefficient and so on. So let's do that. And a lot of it, this is revision. On your assignment, it says at some stage, probably near the end, write a report about the data that you've been given. And so this is what you'll be doing, is basically all this. So the first thing, or you will have done, the first thing is, at some stage in your assignment, you're asked to comment on the association. If we go back to that previous slide, construct a scatter plot, well, you've done that, obviously, and investigate the nature of an association. So when it says, and you might need to make a note of this, when it says investigate the nature of an association, what it means is it positive or negative? Is it linear or not linear? Is it strong, moderate, or weak? And are there any outliers? Remember doing all that? Yeah? So that's what they mean when it says comment on the nature of the association. So the kind of way in which the data is associated. So obviously this one is negative, this one is fairly strong to moderate. It's linear, obviously, and there's no outliers. And there's one other thing, well, it's not really one other thing. Part of the point about this, it's also, at this point, you can mention what the R value is, which you will have got by going onto your calculators. So that's just confirming what you've just been saying. That sort of reinforces that it's strong, it reinforces that it's negative. Negative 0.964 is the number down there, so that's obviously confirms that it's strong, confirms that it's negative. And assuming it's linear, which it is, then you can use R. So really we've done the first two. We constructed a scatter plot to investigate the nature and calculate the correlation coefficient, which is what, so those are the first two steps, I should say. First step is do the scatter plot and make your words about it. Second step is to include the value of R in it. All right, the second one is, which you've already got if you've got R, is to make a note of what the equation of the straight line that goes through there. And we don't really call it the line of best fit because it's more mathematical than that. It's what they call the least squares equation. And I went through least squares. You'll need to know when you do your residual analysis. Remember the distances from each point to the line? You have to measure them, well, that's what the calculator does. It measures the distance from vertical distance from each point to the line, squares those numbers, and does some fancy maths to work out what the smallest total that you can get is. Obviously, if your line went wonky like that, you're going to have big distances, and your total of the square numbers will be very big. So you fiddle around until it's small. Now, the components of the equation are the gradient and the intercept. Yeah, y equals ax plus b. So here's your intercept, which you get from the equation, because the equation was 35,100 minus 3940 times the age. So that's y equals a minus bx. And I did explain sometimes they give you the a, sometimes they give you the y-intercept first, and sometimes they give you the gradient first. But this way they've done this. Y-intercept first, so you've got to show that you understand what this equation means. It means that the graph starts here, 35,100 on the 0 line, and each year the line is going down by $3,940. The little note down here, which hasn't been mentioned in class before, is when you're doing your report, now you will have made up a story, you've got your head around that, you make up a story that goes with the data that you've been given, and I did say it can be a silly story, it doesn't matter. But just bear in mind that if your silly story, or your realistic story, whatever it is, does it make sense to have a value of 0? Age 0 means before anything starts, like brand new, so that would be perfectly sensible. But I can imagine there's some part of your explanatory variable that maybe can't be 0. So just say it can't, even though you've got to work out what the y-intercept is, that may mean nothing at 0. I don't know, you have to think about your own data to do that. R squared, the coefficient of determination. Now, remember how to get that from R? R just squared. It should be on the calculator anyway, R squared. What do you do with R squared when you've got it? Supposing R was negative 0.964. So 0.929. The answer is 0.92, and it's a positive number. Now, how do we use that coefficient of determination? How do we translate it into a statement about the predictive power of this association? Anybody remember that? What you do is you turn his number 0.92 into a percentage, multiply it by 100. Thank you, 92.9. 92.1%. Now, how do we use that 92? Do you remember what to do with it? What you do is you write some sentence that says 92% of the change in price can be explained by the change in A. Square the R, turn it into a percentage, and then write a sentence. Why do we, having got that, you write that sentence down, and then you're actually going to make predictions. You said that 92.9% of the change in the price of the car can be explained by the age. That gives you, it's 92.9, it's a very high number. You can say, I can confidently make predictions. Now, this is the new stuff. I'm going to stop roundabout here, but if you want to, if you've already, totally with what I've been saying, this is what comes next, and I'll do this tomorrow. I'll start it now, and I'll mention it. This is where I'll pick up tomorrow's lesson. You are going to make predictions. You're going to say what the price of a car is when it's exactly 6 years old, which is here.
Can't you just put that into the equation?
You can. That's exactly what you do. You put that into the equation, which is what I'm going to be talking about tomorrow, and you're going to come up with a number like $14,000 if you're looking for 6 years. But you need to know that that is called interpolation, and it is a valid thing to do.
What if the percentage is really low?
I read somewhere the other day that you can go down to about 23% before you can no longer make predictions, and I found that really strange. But 23% is weak. It's bordering on none at all. You can go down to weak, but you must say this is, you can't be confident about that prediction. Because if you've got a weak one, you're going to have a scatter plot like this, aren't you? Sort of all over the place, but it's still a detectable line. So you just have to be big. We don't go into this about when you can make predictions and when you can't. But you're just saying, you might write some flannelly sentence like, I got 92.9%, so I can be very confident or reasonably confident. Maybe you could do that. Now, interpolation is when your prediction, your 6 years in this case, is somewhere between the smallest data that you've got and the biggest data. That's why it's called, that's interpolation. If you make a prediction for, say, a car that's 10.5 years old, that's outside the data. Or if you make a prediction when it's 6 months old, that's outside. So that's called extrapolation, and that is more dodgy. It's in the sense that you don't know from this data that it's going to continue in a linear pattern. If it was a car, if you made a prediction here, you're saying it's negative $5,000. How can a car be negative? Pay somebody to take it away? You wouldn't sell it for much, would you? So that's nonsense. Obviously, this data should actually level out, so it ceases to be linear, and you can no longer make a valid prediction. So extrapolations you've got to treat with caution. You may be able to make extrapolations on your data. Can I come back to this again tomorrow and go through all that again? But that's where you're going next if you want to know. So I'll stop there. And could you work on exercise 3C, the first 6 questions cover what I've covered here. Now that would be a very good idea for you. Exercise 3C, the first 6 questions, just to make sure you've got all those steps and you know how to do all those steps. Like